Time once again for some everyday science, and we have Professor Ernie McFarland and lab technician Tom Kehn from the University of Guelph in Ontario here. So guys, I see a couple of boards here, some ball bearings. What's the deal?
Well, this thing is called falling faster than gravity.
Okay.
Now, you wouldn't think that anything could fall faster.
Is that possible?
Well, what we're going to see is that at least parts of objects can fall faster than gravity.
Okay.
So we've got a couple of boards here, one on the table and the other is hinged. You can see there's a hinge down here, so this one is free to flop up and down.
Okay.
Got a little acrylic cup and a screw nail and a little propping piece of wood. So I'm just going to prop this up with this piece of wood.
Looks like a trap of some kind.
Almost. You wouldn't want to get your hand in
No,
under there
right.
in a moment. And I've now got a ball bearing that I'm going to put up here. And you notice that the ball bearing is below the lip of the cup.
Right.
Okay? Now, in a moment, Tom is going to pull this piece of wood out from under that.
Okay.
And this piece of hinged wood is going to come falling down, and the ball bearing is just setting on the screw nail. It will also fall down. It won't be attached to the screw nail, though.
Okay.
So let's try this out. And again, remember, the ball bearing is below the lip of the cup. So it's starting lower down.
Okay.
So, Tom, away you go.
Okay.
Now,
It went right in the cup, Ernie.
went in the, it always does.
It always does.
It always does.
Okay.
Now that's sort of surprising
Yeah.
because it started off lower than the lip of the cup. And well, let me just show with two ball bearings. Normally, if you start off with something that's lower than something else, and you drop them at the same time, the one that you drop lower ends up going down and hitting the tabletop before the other one.
Sure.
Right?
Okay.
But now, in this case, this ball bearing, which was lower than the lip of the cup, it ended up inside the cup.
Right.
Now, you have to think, how could that be?
Exactly.
The whole thing gets released. What happened, and I'll talk about why in a moment, what happened is this cup actually fell faster than gravity. So we got this ball bearing, and the cup falls faster than gravity.
The cup, okay.
The ball comes down, falling at the gravity rate, and falls in the cup, which was already down there.
Huh.
So,
Okay, does it also, it has to move ahead to the cup, or is that just its
well,
angle?
we had sort of angled it
Here's
up.
the slow motion. It did fall in the cup.
Here we go. The ball just fell straight down into the cup.
Oh, okay.
Okay, because of the angle here, the cup actually kind of moved off. People watching here, there we go.
Okay.
So that goes down, and the ball falls straight down into the cup.
All right, so what is the explanation? How does this board affect things here?
Well, the board is hinged, so different parts of the board fall downward at different rates. The end of the board falls faster than this end of the board. It's got more distance to travel.
Okay.
So it's somewhere near the center of the board that's falling down at the gravity rate. The end of the board is falling faster than gravity, and this end of the board, where the hinge is falling down very slowly.
Right.
So out here at the end of a hinged object, we can get something falling faster than gravity, the cup, and then the ball falling at the gravity rate falls into it.
And the ball just hops right off there. Thank
Yep.
you very much, Ernie.
Okay.
Tom?
Thank you.